Hi, hello everyone. This is Dr. Manur Brahmayya, Associate Professor, Department of SNH, dealing with chemistry, MLR Institute of Technology, Hyderabad. Today I am going to talk about saturated calomel electrode. What is saturated calomel electrode? We have to talk. So, only one single topic. We are talking about the saturated calomel electrode. Type or class, metal insoluble salt electrode. This is a metal insoluble salt electrode, secondary reference electrode. We already spoken about the standard hydrogen cell as a primary electrode. We are talking about the metal insoluble salt electrode. Components, electrode component, platinum and Hg. Electrolyte component, Hg2 mercurous chloride, and KCl is the electrolyte. Karos, beautiful. Malas, black. This is a Greek word. Calomel is a Greek word. Karos means beautiful and malas means black, because Hg2Cl2 reacts with ammonia, it will become black. In historical literature, it is showing that this mercurous chloride Hg2Cl2 is a medicine for syphilis disease. But instead of taking a recovering of the syphilis, it usually gives the many side effects, so that it was stopped to give as a medicine to the human beings. So, construction of the saturated calomel electrode. It consists of a broad glass tube, mercury liquid present at the top of the glass tube, and mercurous chloride paste is present below it. A platinum wire is used for the electrical contact, which is dipped into the mercury. Platinum wire is sealed in a glass tube. The side glass tube is used to fill in KCl solution. The side arm can act as a salt bridge. So we can see the figure first. This is the porous wick. This is the hole. KCl crystals and saturated KCl and mercurous chloride Hg2Cl2 KCl, filling this hole with this mercurous chloride Hg and to the potentiometer. This is the diagram. The potential of the calomel electrode depends upon the concentration of the potassium chloride solution. Based on the concentration of the KCl solution, the calomel electrode is of three types. One is saturated calomel electrode if saturated KCl solution is used. Normal calomel electrode if 1 normal KCl solution is used. Deci-normal calomel electrode if 0.1 normal KCl is used. These are the three types. You can see here: saturated calomel electrode and normal calomel electrode and deci-normal calomel electrode. These are the three types. Based on the depends upon the concentration we are taking KCl, it is represented like three different electrodes. The standard electrode potential of the saturated calomel electrode is 0.2422 volts. The standard electrode potential of the saturated calomel electrode is 0.2422 volts. The standard electrode potential of the normal calomel electrode is 0.280 volts. These are already practically proved and determined values. The standard electrode potential of the deci-normal calomel electrode is 0.334 volts. These are the three different values of these for these three different calomel electrodes. Based on the concentration of the KCl, we are dividing them and their respective volts of the electrodes. Working of the saturated calomel electrode. The saturated calomel electrode acts as a cathode or anode based on the other electrode it is attached to it. Same like a standard hydrogen electrode, how it is worked based on the depends upon the how we are taking the other electrodes. If it is anode, it will act as a cathode. It is cathode, it is acts as a anode. So like that, the same way the saturated calomel electrode also will act. When the electrode acts as anode, Hg gets oxidized to form, mercury gets oxidized to form Hg2 2+ and electrons are released. Whereas Hg2+ ions will combine with Cl- ions and to form mercurous chloride. So we can see it is an oxidation reaction. 2Hg gives rise to Hg2 2+ ions and 2 electrons. And Hg2+ ions plus 2 Cl- ions gives rise to Hg2Cl2. It is a reduction reaction. Overall reaction at anode is 2Hg plus 2 Cl- ions gives rise to Hg2Cl2 plus 2 electrons. Electrode representation is platinum slash Hg slash Hg2Cl2 slash KCl. This is the saturated calomel electrode representation. When it acts as a cathode, mercurous chloride dissociates into Hg2 2+ ions and Cl- ions. Hg2 2+ ions combine with the electrons and forms mercury. And Hg2Cl2 gives rise to Hg2+ plus 2Cl- ions. Hg2 plus 2 electrons gives rise to 2Hg reduction. This is already reduction. 2 electrons, by gaining the 2 electrons, this metal is becoming a 2Hg. Overall reaction at cathode is Hg2Cl2 plus 2 electrons gives rise to 2Hg plus 2 Cl- ions. This is the overall reaction. Or half Hg2Cl2 plus 1 electron, single electron gives rise to metal, Hg metal, mercury metal plus chloride ions in the aqueous solution. So electrode representation KCl slash Hg2Cl2 slash Hg slash platinum. This is the representation of the electrode representation. Applying the next equation for the net reaction, electromotive force E cell is equal to E0 cell minus standard electrode potential minus 0.0591 by number of electrons transferred log Hg by Hg, concentration of the Hg, concentration of the Cl- ions and overall product Hg2Cl2 concentration. The E cell is equal to E0 cell concentration minus Hg2 overall representation of the cell minus 0.0591 log Cl- ions concentration. The Hg and Hg2Cl2 are unity, therefore the E cell depends on the concentration of the chloride ions. Hence the electrode is said to be reversible with respect to the chloride. Another electrode which is reversible with respect to the chloride ions is AgCl. This is the way how we are going to find out the E cell using the Nernst equation. We will discuss about the Nernst equation in the next video. Advantage of the SCA, saturated calomel electrode. It is cheap and easy to transport, easy to construct and maintain the cell. Used to calculate the standard electrode potentials. No need of the salt bridge, and the slight change in the temperature also may not affect the potential of the electrode. Summary. The presentation covers the construction and working of the saturated calomel electrode SCA, its advantages. This is the overall presentation of the SCA. Thank you.